Okay, so problem 50 is the problem with the spider web, and there's a big insect caught on the spider web. Um, the thread breaks if the stress is 8.2 times 10 to the 8 newtons per square meter, um, and the strain is 2. Um, okay, strain is 2. So this initially it was horizontal. It had a length of 2 centimeters and a cross-sectional area of 8 times 10 to the minus 12 square meters. Um, as the thread is stretched under the weight of the insect, its volume remains constant. If the weight of the insect puts the thread on the verge of breaking, what is the insect's mass? All right, we're on the verge of breaking. And so that the strain is 2 tells me that the change in length divided by the length equals 2. That means the change in length for this web with the spider on it and with the insect on it is 4 centimeters. So now the whole thing is 6 centimeters long. And if we look at this and we say, okay, we have 3 centimeters there, and we have, what would this be? Started out as 2 centimeters. We have 1 centimeter here, right? Then we can figure out that angle, and we can figure out that distance. That angle is just from the inverse sine of 1 centimeter over 3. So inverse sine of a third is going to give us this angle. And then that distance is square root of 3 squared minus 1. So square root of 8 is that distance right there. Okay, so that was just the Pythagorean theorem, right? Let's get that angle. So the angle there at the bottom between the vertical and the 1/3, right, is the vertical and the thread. Okay, so a sine of 1/3. And let's get that in degrees. So 19.47 degrees. 19.47 degrees. Make sure I got that right. So we're talking about, we have our vertical, we have this, that's 3, that's 1, and 19.47 degrees is what we're getting for that angle right there. 19.47 degrees, or 19.5 degrees. Okay, and then the length of the other side, just call it L, is square root of 3 squared minus 1 squared. Square root is square root of 8. I don't know that we need this yet, or at all. All right, 2.83 centimeters. Okay. So the so now we know how far it has gone down. The tension on the tension on the thread, spider web, is what's holding up and opposing the mass of whatever it is, right? We got its weight, mg, and we've got tension here, we got tension here. Well, now that we have this angle, 19.5 degrees, t times cosine of 19.5, right? Twice that. Once for the side, once for this side, must be equal to that. All right? So tension is supporting the weight of the bug. And so we end up with 2t cosine of 19.47 degrees equals mg, the mass of the bug. Okay. We also know we're on the verge of breaking, and that the let's see, we have the cross-sectional area when it was horizontal, right? Now we're being told the thread breaks under a stress of 8.2 times 10 to the 8 newtons per square meter and a strain of 2. Now we set the strain to 2, right? We set the strain to 2 by saying it's now 6 centimeters long. And that gave us that angle. There's that angle right there. Now we're going to set the cross-sectional area to its new cross-sectional area, because what I say here is that the volume is constant. So what's the volume we start out with? We start out with a volume that is 0.02 meters times 8 times 10 to the minus 12 square meters, right? That's its initial cross-sectional area. That's its initial length. And so 0.02 times 8e minus 12. So we get 1.6 times 10 to the minus 13 cubic meters. That's its initial volume. We know that it still has that volume, and so what we're looking for is what is the cross-sectional area, because it's now 0.06 meters long times a new area equals 1.6 times 10 to the minus 13th cubic meters. Right? So the area is 1.6 times 10 to the minus right? Divided by 0.05 is 3.2 times 10 to the minus 12. 3.2 times 10 to the minus 12 square meters is the area. And we've already enforced that the strain is 2. Now we're going to enforce that the stress is 8.2 times 10 to the 8th. The stress is just F over A, right? F over A, which is mg over A. That's the mass of the bug, is the force down on it, mg over A, times, equals, mg over A equals 8.20 times 10 to the 8th newtons per square meter, right? Square meter, M62 newtons per square meter. All right, we're looking for the mass. We have the area now. Area is 3.2 times 10 minus 12. We know G. We're just looking for the mass. The mass is A over G times 8.20 times 10 to the 8th newtons per meter squared. Right? I'm going to stick in the area. I'm going to stick in G. Area divided by 9.8 times 8.2E8. Okay, and so we get a mass of 0.000268, which is 8 kilograms, which is 0.268 grams. All right, and that is the mass of the bug. And that is it for problem 50.